workshop. All right, I am Tamika Lodge Fenton, and myself and Carol Harris will be presenting to you today on trigonometric ratios and rules. All right, so let us begin right away, guys. I hope you're all feeling well, and I hope that you are. I know it's your holidays, but I am so grateful that you saw the need to come on and to join us. My camera will be closed for the rest of the presentation, just to make sure everything flows well, guys. All right, well, I'll open it in between. So now here we are. Our first thing before we get into any content, our brain teaser. Now, I hope most of us would have known of the game. You have 4 picks and you use one word to describe those 4 picks. So we're going to do 2 levels within this game and then we'll move on just to get your brain going. All right. I just want to make sure everyone is paying attention. Open your mic, everyone, and say good morning so I can hear you out there in the virtual land.
Good morning. Good morning.
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 Morning. Okay, nice. All right, great. So remember, guys, before we even begin, learning is not a passive thing. So in order for us to be successful today, for you to get the best out of the presentation, and for myself to ensure that we interact well, I need us all to be conversing. You are not supposed to be passive learners. You're supposed to be engaged and involved, active learners. That's what we want. Understood? You can always use the reactions and put thumbs up and any emoji that is respectful. Great. Look at Abigail. Abigail, did I ask you to answer already? All right, great. So we have 4 picks here and you have a set of letters. And yes, I want you to respond in the chat which word best suits this particular set of pictures. And I'm seeing everyone is chiming in and we pretty much know that everybody is on the right path. Awesome. Thank you, Justin. And we can now look at the correct response for this. And this is angle. Awesome job, guys. Next pick. Here we are. We have 4 images. One over there, a shape with a exclamation in it. We have okay. I see what is this? Danielle. Okay, Justin chiming in there. All right, awesome. So I see Abigail, Sasha Gay. Great job, guys. So we can definitely, yes, Christopher Jones, we can definitely chime in. We can now look at the correct response for that because they're just all blowing up the chat. Awesome stuff. Yes, triangle. All right. So there's math in everything, guys. So today's session, let us look at what we want to cover today. We want to explore the trigonometric ratios of acute angles in a right triangle. We also want to apply these trigonometric ratios to solve problems, as well as explore the sine and cosine rules and use these 2 rules to solve problems involving triangles. So those are the things that we want to explore today. Now let's just do a little let's open up our brains and see what's in there so we can, before we go on any further, guys, I'm asking you one more thing. Type in the chat which school you're from. Do that now before we go any further. Just type the school that you're representing today, whether you're a teacher or a student, type the school that you're associated with. Thank you so very much. Giving you 30 seconds. Okay, awesome. Thank you so very much, guys. I'm waiting for the rest to come in. iPhone, the person who has iPhone as your name, if you could just quickly go in and rename yourself, it is easier for me to talk to you if I actually have a name. I don't want to call it an iPhone for the session. Your first name is fine. All right. Thank you, Roxanne. All right, great. So we seem to have a variety of schools. If you have not yet put your school name in, please do so as soon as possible. We have a mixture of students and we just want to know who's represented here. Awesome stuff. All right, so let us recap a little, or let us see what's happening in the brain. How do we find the missing side of a right triangle? Now, raise your hand. Feel free to open up your mic and speak to me, or you can type in the chat. You're given triangle 1. You have 2 sides, 2 known sides, and a missing side. All right, Dana. All right, I see Dana has put in her response. Anyone else want to tell me how would we find side B? In agreement with Dana, or you have a different method? All right, Sasha. Sasha, remember what we said, we're trying to find the missing side. Who is speaking?
Right, so the side that's being highlighted, that's the side we're trying to find.
Open. All right, guys. So we have a few responses. And yes, definitely, when you are given 2 sides and you'd like to find the missing side, Pythagoras theorem is the one that you would apply. What if you have this triangle though? So now you have 2 sides that are unknown. You are given 1 angle and you are given 1 side. What would you use to find side B or side A, side C? Where am I finding side A? So Dana, you're right out of the box. You are there. Great. Trig ratios.
Oh,
all right. Sokotoa. Go, Dana.
Dana is on top of it, man.
All right. What am I calling her, Dana? It's Danae. Danae, open your mic. How's your name pronounced?
Danae. Good morning.
Danae. Hi, Danae. Good morning. All right, great. I see.
National.
So when we have 1 known angle and a side, trigonometric ratios can be applied. Now, why do we need to even look at this? When you are working with right triangles, you need to be aware of what you're given and what is the applicable thing to use. And that's pretty much why we just wanted to go through this little exercise. All right, let us continue. Now, what is trigonometry? In your own words, is that Julisse, Francis? You want to tell me what you know about trig?
No, Miss, I'll pass.
No, it doesn't have to be wrong or right. It's really, I just want to hear from you. You've heard trig before? Trigonometry?
Yes, Miss, I've heard of it and I've done it before.
Okay, so what do you think it is? You don't have, remember, the word think means what would you what would you get from your interaction with it? So it's not about wrong or right. Just tell me what you think trigonometry is.
Trigonometry.
We can't say live screen.
Yes, go ahead. All right, Julisse, you gone? All right. Anyone else? What about Gabrielle? Abriana?
Oh, sorry, Miss. I accidentally mute. I'll try.
All right, go ahead.
Trigonometry is a study of a mathematical branch, I guess.
All right, it's a mathematical branch. It's a branch in mathematics. All right.
Is it Deshawn that says trigonometry is a study of missing angles and sides? But that's a good start, Deshawn. But what else would you say? Would it be the missing angle of a pentagon, of a hexagon? What would you say? You could open your mic or you can type. The study of missing angles and sides of a circle? What do you think? of a triangle. Okay. Will you go with that, Mrs. Lodge Fenton?
Yes, we can go with that, most definitely. We can fine tune it, or we can just, we can run with that. That's a good way of looking at it. Right angle triangle, all right. So remember, guys, when you're in the learning, when you're in a classroom or a session, it's okay to say what you think, because we kind of want to know what's in your head so we can make adjustment. Learning is not stagnant. We learn things every day. So it's not about right or wrong, but it is having a discussion. So we know what you're thinking and we know how to help alter, change, manage that thinking. All right, great. So trigonometry, let's see what trigonometry is according. So I thank you for everything that you have said. Trigonometry is a branch in mathematics that deals with calculations of angles and sides. That's Justin. Trigonometry is basically related to sides of angles, sides and angles of triangles, or with functions of any angles. All right. All right. I see Sasha gets it. It finds the sides and angles of any triangle. Great stuff. So trigonometry is a study of angles and dimensions of triangles. So pretty much several of you are right on target. You realize it's about triangles. It's about the sides and the angles within the triangles. Great stuff. You think that's okay, Carol?
I'm good with that, yes. Most of them have that on the, that is why I asked about and then she corrected herself on the triangles. I'm perfectly fine with that, yes.
All right, great stuff. So here we are now. Trigonometry is a vital part of modern engineering, design, architecture, and other fields. So a lot of times you are engaged in topics, guys, and you're not sure why you're doing it, but we're telling you, Trig helps with all these things that I've just mentioned. So let's get right in the stuff. All right. Some of the uses of trigonometric ratios in real life. I want one person to tell me how they think or they know trig has been applied in real life situations.
Let's see those raised hands and let's hear you talking.
You know what I'm going to do if you don't talk, I'm going to just pick on you, you know. Danae? Is it Danae? Or yes, Danae. She said Danae. Danae Peters? What have you ever seen trig in real life? Or do you think?
Maybe not seeing it, but probably like architect persons when they're drawing for the houses, they have to do it at a certain way, or even when they're putting up probably light posts, they have to do it at a certain angle or so.
Good job. Good job. That's good. You're thinking. Awesome. And that's all I need. I need you to just think and tell me something. So let us look at a few ways in which we see trig being used. Measuring grounds, lots, fields.
Directions.
What was that?
All right, measuring directions like north, east, south, and west.
All right. So you're looking a little bit at bearings. Measuring directions. All right. Good job. So making sections of a building perpendicular or parallel to each other. These are all ways in which trig ratios are used in real life. So installing ceramic tiles and stones. How many persons knew that trig was used to install tiles? And you know, those stone walls and stone stuff. Open your mic and say yes or no. If you know it, say yes. We can't have a quiet session, guys. We have to talk. All right. I see you guys are typing in the chat. Awesome stuff. All right. So yes, installing tiles is a way in which trig is really applicable. If you've ever looked at some of these workmen, if you've seen construction around, they walk with this. Team, help me out. It's an L ruler that they have. I'm going to call it an L ruler. I'm not sure if that's what it's actually called.
Square.
What was that?
I think it's called a square.
A square.
A T-square. T-square.
Okay.
No,
It's a
not
metal,
the
set square
not the
in
T
the
square,
geometry
but
set.
not the set square, you know. It's like it's a metal ruler that they use. It's an L, right? It's shaped as an L, and they use it to form. So it would have given them the two legs of the triangle already, and they pretty much use it to find out if the building is square. It's their 90 degrees. So they put it against the wall and they see if it's flush with the wall, and they form their stuff when they're doing the floor as well, the tiles. So if you really were to investigate some of these jobs, you'd see how rich the math is in these construction that is being done in our homes and our buildings. All right, awesome. Let's look up some other ways. So here we have just a little diagram of a roof, and trig can be used to investigate the roof inclination or the roof slopes. All right, and you see the right triangle form there. You see the rise and the run, and you see the pitch angle, which would be, and you see the labeled section as the rafter length. So you see the triangle being formed out there, guys. And this can be used. So if I know the length of the raft length on the left side of the roof, I just have to double it. Once I've used a symmetrical roof, and I would know how much material I would use to cover that entire roof, or was used to cover the entire roof. So a lot of information can be gathered from this. And this is trig in real life. All right, let us look at this, the height of a building. Now, I don't know if you've ever wondered how they know that this building is taller than that one. How do we know the tallest building in the world? Clearly, somebody out there has been doing some calculation. And pretty much, I'm sure no one thinks someone goes to the top of the building and drop a tape measure that is way long and say, hey, down there, look how long this is. No, that's not how it works. So trigonometry would be applied here once more. So as you can see, some terms there, angle of elevation would be important, and the distance from the building to where the angle of elevation is formed. Those are important points as we employ the trigonometric ratios to find out the height of really tall buildings, or even short ones too. All right. So now that we've looked at trig in real life, let us take a look at relating angles and side of a right triangle. So let us review the basics. Here we have a triangle. It is labeled ABC. And let's just recap some basic things that we all should know. But just in case you didn't remember, can't say we didn't do. The angles of the triangle are labeled with what? Capital letters. And the sides are labeled with common letters. As you can see, you have that little arc that is used to denote an angle, X, and you have a square there, which is used to denote a particular type of angle. What kind of angle is denoted by that square? Put it in chat. Right angle, excellent, thank you. Right angle, so once you see that little square in the corner, you know it's a right angle, excellent. All right, so that's labeling of your triangle. Let us look at some important points we can get when we understand the labeling of the triangle. The side opposite to an angle is the side that is facing it in the triangle, all right? So we have big C, which is the 90 degrees angle. Who knows what the side C is? Small c, that side that is labeled C. Who knows what is that side? We all should know this. Most of us should know this. So C, what side is that? When I come to angle.
What's the special name for that side?
Right, thank you. What is the special name given to that side? Excellent. It is the hypotenuse. Great. So what can we say about the hypotenuse? The hypotenuse, it's always what? It's always the hypotenuse, it's always what? It's always opposite to the right angle. Excellent. Yes.
What else? What do you say about it? It's the longest side. Great. Thank you for that, Jonathan.
Good. Yes, Sasha K. It is
Jonathan, the longest side.
All right. So it is always the longest side in a right triangle, and it is opposite the 90 degree side. Let us do a little bit more investigation. So the side B is opposite to angle B. Does everyone agree with that statement? That side B is opposite to angle B? All right, great. All right, so here the angle B is at the top of the triangle while the side B is at the bottom. Similarly, when we look at angle A, the opposite of angle A is side A. And angle A is on our right and the side is on our left. All right, great. All right, please pardon me for that right there. Oh, did I have that right? Angle A is on our left. Yes, it's correct. Great. All right, so let's look at the next point. We know this, but let's just recap it. Hypotenuse is always the longest side, and it is the opposite to the right angle. So side C is opposite to angle C. Great. Now, I don't want you to study the side C or the side whatever. I want you to understand that once you identify the 90 degrees angle, the side that is opposite to it is the hypotenuse, because the triangle may not be labeled ABC in this particular way. And your 90 degrees may not be at angle C. So that's the first thing I want you to understand. I want you to understand that the 90 degrees angle is what you want to identify. The side opposite to it, and which is the longest side, is the hypotenuse. Hypotenuse, great. Then the last point I want us to look at, the adjacent. So the first thing to do is, yes, that is excellent, Abriana. You can identify the 90 degrees, and then you can definitely identify your 90 degree, your hypotenuse. Great. So here we are, the adjacent to an angle is the one closest to the angle. That is, so if we're looking at side A, what angle is closest to it? Angle B. So side A is adjacent to angle B. And then we can further say side B is adjacent to angle A. Everyone's following? Say yes. Or
Yes.
great.
Yes, Miss.
Yes,
Awesome
miss.
stuff. Great. All right. So that's just looking at things that you would have been doing. We just want to make sure that your brain is ready and it's bringing back all those things that you would have engaged with. All right. Let us move on. So here we are, the trigonometric ratios for right triangles. So here we are. Now pay attention. I have identified only one angle here outside of the 90 degrees. We have to identify the 90 degrees because we are dealing with what kind of triangles? Open your mic and speak.
Right angle.
Right angle triangle, right triangles. That's what we're dealing with. So it always has to be there. All right. So you see the hypotenuse labeled. The opposite is in relation to angle A, and the adjacent is in relation to angle A as well. All right, because that's the angle that we are focusing on. So now let us look at the trigonometric ratios as it pertains to angle A. So the sine of angle A is equal to the ratio of the opposite side and the hypotenuse. We're going to investigate this a little bit more, but we're just reviewing what you would have engaged with already. The cos of angle A is equal to the ratio of the adjacent side and the hypotenuse. And then you have the tangent of angle A is equal to the opposite side and the adjacent side. No need to swap this, guys, because guess what happened? You have an acronym which we'll investigate, which we'll explore. SOHCAHTOA, which several persons had mentioned in the chat earlier. SOHCAHTOA, which helps you to just remember that sine has to do with. So sine has to do with what? Opposite and hypotenuse. Cosine has to do with adjacent. Great. Thank you, Abriana. Has to do with, what did I say again? Cosine? that is adjacent and hypotenuse. And then your tangent has to do with your opposite and your adjacent sides. Great. So let us look here. So here we have a well-labeled triangle. Both angles are in here, but we're going to focus on angle B and angle A differently. So if we're looking to find the sine, before I put it in, type in the chat. You can use your slash to come up with the correct thing. So angle B, what would be the sine ratio for angle B? Using the letters that are labeled on this triangle.
It's what do you mean?
Okay, so remember I said you have the angle of a side, the sine of an angle is equal to a ratio of any two sides. So what two sides? We have side A, B, and C. What is the ratio that will give us the value for angle B? If we're looking at the sine of angle B, what two sides would I look at? Would I use? Okay. You understand what I said? Was I clear on, or I just further mixed you up?
Me somewhat, but I think when the answer, then maybe it's going to help me
So
interpret
you
for
want to
you.
start by saying
Yeah.
sine of angle B equal like what Justin just did.
All
Sine
right.
B.
Okay, Justin, right. And Dana, she did the same thing. So sine B equals B, the ratio of B and C. All right. All right, so let's just look at it in the table to see if you guys got it right. So yes, it is. So since we're looking at angle B, we're gonna look at E, what is the opposite side to B? Remember that we said sine has to do with the opposite and the hypotenuse. So it is the opposite side that is being divided by the hypotenuse that is going to give us the value for the sine of angle B. So when you're looking at angle B, the opposite side is side B. And then you know, of course, that C represents the hypotenuse. So it's B over C. Now, what about angle A? Same sign, so sine of angle A. What would you write? What would be the ratio that you would express? I know probably you've never seen, probably using the term ratio there for you. It's not the way that it is normally said. So let me see. What two sides would you need? Would you use to find the angle, sine of angle A then? All right. All right. All right, let's just check it out.
Length of A over length of C, or length of A
Mhm.
divided by the length of C.
Right.
Several of them are showing that.
All right, let us see it. Let's just see in the table. All right, great job, guys. All right, so right away, we now move to the cosine of angle B. So you should pretty much understand. Great, Justin. So you should pretty much understand what we're looking for. If you are dealing with angle B and you're using the cosine ratio, what two sides would you be using? All right, and we have AC there. Let us see what it is in the table. All right, and cosine angle A. What two sides would we be using here? All right, so I need to know what's happening. In the chat, tell me if you understand where we are and where we're going with this, or you are not understanding. Say something, use the reaction
Yeah,
button.
man, they're responding, Mrs. Fenton.
Okay,
So
great, I saw them coming now. All right, great.
Danae and
All right.
Sharon. We have it as B.
Can you
right?
just for the sign, could you just tell us how we arrived on both our answers, please, so that for cosine and tangent we're a bit more able to fully understand confidently.
All right. Who just spoke?
Daily, Abriana.
Abriano, ask me the question again.
For sine, could you explain how you arrived on the answers for angle B and angle A?
All right then. All right, so we have angle for the sine of angle B. That means we're using the sine ratio, which states that when you have an angle, if you were to find a value for the sine of that angle, it would equal the length of the opposite divided by the hypotenuse. And you agree with me with that, Ariana?
Yes, miss.
All right. So what letter represents the opposite side on this triangle that we have? If we're looking at angle B, what side is opposite to angle B?
Miss B.
Good. So we would put B, we would substitute the word opposite with B, because the opposite side is represented by whatever value would be in place of B. All right? And what is the letter that represents the hypotenuse here?
Miss C.
C. So that means the sine of angle B is equal to whatever length. So if I had 5 at B, I would put 5 where the B is now. And if I had 7 at C, it would be 5 divided by C. It would give me the value for whatever sine B works out to be. That makes any sense?
Yes, miss. I understand now. Thank you.
Okay, great. You're welcome. All right, so we can fill him at the table. So we have angle B is B divided by C. Those would be the lengths. And that's the sine of angle B. The sine of angle A would be A, side A divided by side C. And as you can see, C is the hypotenuse. And for the sine of any angle, that the ratio, or it's equal to the opposite divided by the hypotenuse. The sine of any angle within this triangle is equal to the opposite side divided by the hypotenuse. Everybody following that? You can say no. If you're following, say yes. If you're not, you can say no. All right, great. And the cosine of any angle, within the triangle, so we're now, it is equal to the adjacent side divided by the hypotenuse. Adjacent over hypotenuse. Great. So angle B, so cos of angle B is going to equal, what is the adjacent side if we're looking at angle B? That is the side closest to angle B. Touching, it's one of the legs that is forming angle B. So that's side A. So great job. Thank you, Sharona. So that's side A divided by the hypotenuse, which is C. So it is A over C. All right. And then we have cos angle A. So now we're looking at the other angle. So cos angle A is still going to need to figure out what is the adjacent side there. So if we're focusing on angle A, what is the adjacent side? Side B. So it's now B. Great. So it's now B over C. That's pretty much what we're saying. Mr. Roberts, I don't know if you realize that your camera is open. It's fine if you want to open it. Good morning. It's fine if you want to open it, but just letting you know it's open. All right, great. All right, so we can now see that cos angle A is B over C. All right, so let us look at the tangent. Oh, so before we look at the tangent, guys, can we have, let us look at everything with cos and sine. Thank you. Now, can you see anything, any pattern, anything, any relation that you want to talk about with sine and cos?
Any similarities, any differences?
There, thank you.
Well, miss, for angle B,
Yes.
for sine and cosine for angle A is the same.
Nice.
And for sine angle A and cosine angle B, it's also the same.
All right, great. So before you, okay, it's opposite. Sharona, what you mean it's opposite? It's the opposite. Oh, see what you're saying, probably. You're saying angle, Sharona, you feel like talking? All right, no problem there. So the opposite, so you're saying that angle B, for the sine of angle B is the opposite of cos of angle B.
Maybe what is sine for one is cos for the other.
That's what I think she's saying. All right, great.
Yeah.
All right, so now let us look at the triangle again. And I want you to work with me. What's the degree? What's the total degree within a triangle, guys? All the angles within a triangle add up to give you what?
180.
180, great. So if we already have a 90-degree angle, if you were to sum angle A plus B, how much would that give you? So if you're adding angle A to angle B, how much would you get? Seeing that you know all the angles add up to
45 is.
All right. Let me
Why
ask it again.
45, Christopher, was that Christopher or Robert?
Miss, when you combine angle A is 45 and angle B is 45, so it's
Oh.
90.
Oh,
Why
Oh,
you think
you're
it's 45 though? What makes you think it's 45?
Because never mind. Because I just 95 by 2.
Could it be 55 and 40 and 35?
It could be.
Okay.
all right. So the angles could be proportionate differently. You could have B being larger and A being smaller, or the opposite way. And you could have them being equal. So that is why I wouldn't want you to say 45, 45. But yes, we'd want you to identify that the sum of the two smaller angles will give you 90 degrees, right? Because 90 plus 90 gives us 180. And we already know that the right angle is 90 degrees. So now having that knowledge, let us look back at what is in the table. So what we're saying, angle A and angle B are complementary. That means when you add them together, they will give you what? You can say it. When you add angle A and angle B together, it will always give you, in a right triangle, that is, it will always give you 90. Yes, it will give you 90, not 180.
180 is the angle sum for a triangle.
So,
Okay, right, 90.
so if you look at sine angle B, whatever angle B is, it is going to be complementary to angle A, right? So if angle B is, for argument's sake, 15, angle A is going to be what? Great. It's going to be 75. Thank you, Justin. Right. So if we look
Miss,
at
that's because we're trying to get the 90, so you subtract 90 from the, 15 from the 90 to get the answer.
correct.
Correct. That's what complementary means. Complementary means that they complement each other and they add up to form 90 degrees, to make 90 degrees. So when two angles are complementary, they sum to 90. Anything for my alpha girl, because I'm an alpha girl.
All right, great. So they're complementary. So as Miss Harris just said, you know what that is now. So angle B is complementary to angle A at all times within a right triangle. So if you look at the sine of angle B, it is the same as the cos of angle A. All right. And the sine of angle A is the same as the cos of angle B. Because remember, angle A and angle B are complementary. So it means that the cos of, how must I say this? The cos of the complementary angle, sine of the angle, are the same. Did I get that right?
Or we can just say for the sine of any angle is equal to the cosine of its complement.
Thank you. That makes more sense. Thank you.
Or the cosine of any
It's
angle is
said
equal to the
better.
sine of its complement.
Did you guys get that? Say it again for me, please, Carol.
So the sine of any angle is equal to the cosine of its complement. So let's type in the chat. If I said to you that the sine of 35 degrees is a certain number, what cosine would that be equal to? Sine 35 is equal to cosine what? Type in the chat. The sine of 35 would be equal to the cosine of what angle? Ask yourself, what's the complement of 35? Great,
Yes.
55. Excellent. And if I said to you the cosine of 25, it's equal to the sine of what? Cosine of 25 is equal to the sine of? Great. We have the idea. I hope everybody got the idea. So the sine of an angle is equal to the, any right triangle, it has to be a right triangle. No, that's not true. The sine of any, yes, the sine of any angle is equal to the cosine of its complement.
Yes.
So the sine of 30 is equal to the cosine of 60. The sine of 60 is equal to the cosine of 30. So the sine of any angle is equal to the cosine of its complement, and the cosine of any angle is equal to the sine of its complement. That's a nice multiple choice question, by the way.
Miss, any choice you could like type it so that we could have a visual, please? Because I'm a visual learner, so I hear it, but
There you go. I get you, sweetheart. I get you. I don't know why I'm doing that, and I'm like that too.
We're going to investigate it a little bit more, but Miss Harris will type it for you. All right. So let us look at the tangent. You can always go to your chat and pick it up, but we are going to do some more investigation on that. Let us look at what we get. So we're now looking at TOA, the tangent of an angle. So the tangent of angle B, what would be the sides that we would be using, the lengths that we'll be using? So tan angle B, we're now looking at the opposite and the adjacent. All right, I see C and A there. So angle B, we're looking at the opposite of angle B. What's the opposite side of angle B? Side B. So it would be B and what? And the adjacent to B would be?
A.
A. Why couldn't it be C? Anyone can tell me why we couldn't use C as the adjacent side?
Just see.
Is it because C is the longest side, which means that it's the hypotenuse?
Correct. And because it already has its role as the hypotenuse, we can't even consider it in the opposite and the adjacent sides. Okay? All right. So now let's just look at tan angle A. Tan angle A, So we're now at angle A. All right, so we're now at angle A. Which side is opposite to angle A? Yes, I would like you to practice using your small letters for sides. Your big letters, your capital letters denote angles. Your common letters, thank you. Your common letters denote sides. Practice it so that you easily make the differentiation when you're looking at items or question papers, or you're working out your own answers. Okay, good, great. So we have tangent of angle A. We'll be using the opposite side, which is small a over small b. All right, awesome. All right, so we've pretty much looked at how we would be able to apply the trig ratios to any given triangle, labeled any way, because you're looking at the angle and then you're identifying the sides that would give us that would form the ratio. Okay, let us move on from here. Afterwards, we'll see what we're saying. So here we are now. So we have specific angles now. We're not just doing it generalized. So the sine of angle 0 equals 0. The cos of angle 0 equals 1. And the tan of angle 0 is 0. Let us look at sine 15. Work it out on your calculators. Tell me the value that you get for sine 15. So you're plugging sine 15. Learn how to use your calculator. Some calculators require to press the sign after, some require to press the sign before. So and sine 15.
0.65.
All right. Hold that in there. We'll see. Give them some time.
I got 0.25.
0.25. All right, let's see. Gonna take just a few more response and then we'll discuss.
A quick one. I'm seeing 0.2588 and I'm also seeing 0.25.
Mm-hmm.
So careful. I see some persons rounding 0.2588 to 0.25. Be careful, because when you actually start working with your numbers, don't round so much. It tends to throw off your answers. Okay, I'm seeing 0.65, 0.25, 0.26. All righty.
All right. So we have a couple of responses. Let's reveal what is sine 15. All right. So the closest would have been, so yes, 0.0, 0.26 and 0.25. You did work it out. You run it off a little bit early. Justin would have put, and Jonathan, along with Danae, would have had 0.259, 0.2588. Those would have been probably the closest to that, because they would have
rounded to 3.
Oh, those were exact. Well, Jonathan and Danae rounded off to the 3rd decimal place, while Justin kept it at the 4th decimal place. As Carol said, be careful how you round off too early. Your answers will differentiate a bit, will be different when you round off too early in the in your working. But yes, now I want you to work out what is
Mrs. Lodge Fenton.
Sure.
I noticed a couple of students had
Oh, how did you get that?
0.65 or 65 thereabouts.
Oh.
And Daim had really typed in the chat just now. How did you get that? And so she would need some clarity on that. Thank you so much.
All right. Carol?
Okay, so I'm not too sure what it might be So some of you need to have checked, this is why this is a good opportunity to know your calculator. For some calculators, you have to put in the 15, then you press the sign. For others, you have to press the sign, then the 15. So I'm not too sure what might be getting the 0.65. And you also have to make sure that your calculator is in degree mode. You'll find that your calculator has a key mark D, R, G. So when you press on it once, you might see D come up. When you press on it another time, you might see R. R is for, there are 3 kinds of angle measure: degrees, radians, and grad. You are going to use degrees. So make sure that your calculator is on degree mode. That is the D. So look out for the D on your screen. So let me see if I can, we do have our calculator up on screen, but you have to be careful of that. So let me see what could have possibly given that 0.65.
No, tell me what you did. What did you do to get the 0.65?
What did you do, Dime? Did you find out, Dime? You want to share with us, Dime?
She has found out.
It was on Radiant. Okay, great,
Okay.
great, beautiful. So that's a good, this is a good teachable moment for everyone. So learn that you have radian degrees. Most of us, those of you who eventually do add math, you will use your rad and your grad, but you don't use it most times for CSEC maths. So you're gonna use your degree mode always. Can I just overemphasize that always? Make sure that your calculator is on degree mode. If it's not on degree mode, it's gonna make your calculations so wrong, so wrong. I don't want to make that happen to you. All right. So I'm glad you found out that. Is it, how is the name pronounced? Is it Daheem, Mr. Roberts?
Daheem.
Okay, Daheem. Thank you.
All right. Great. All right. So here we are. So I want you to know, tell me what would be, so we have sine 15. What angle would you need? Do you think would be the same as sine 15 if you were finding the cos of that angle? What's the complementary angle for 15, by the way?
75.
75. So sine 15 would be equal to what? The cos of what angle?
50.
Cos 75?
Excellent.
Great.
So now use your calculator and determine the value for cos 75.
0.258.
Yes, I agree.
So you see from your own working out that the sine of an angle, let me read what Carol had put. The sine of an angle is equal to the cosine of its complement. Do you agree with that statement?
Or do you see that happening now, that the sine of 15 degrees rather, is the same as the cosine of 75 degrees? And you can
Okay.
check it on your calculator as well.
No, I don't understand. Yeah.
So look at the
Okay.
table carefully.
Oh.
So
All
30
right,
degrees is 0.07 then.
30 degrees of what?
No, never mind.
No, 30 degrees. What is it, sine or cosine? You have to tell me. You're talking about sine 30. Sine 30 degrees.
Yes. There's
Right.
no,
So
but there's a value for both sine and cosine, and they just flipped. Because the bottom is 1 for sine and the top is cosine, 1 for cosine. So they're kind of like the same, but upside
they're
down.
upside down. Okay.
So let's.
I know what
like
you're
that.
trying to say.
Yeah, so it's
All
like,
right.
each of them, the column is in the reverse order, but it's
Right,
also
right. All right. So the person who said you don't understand, talk to us. What don't you understand?
So I see it now, Miss. Never mind. I see it
Okay,
now.
great. All right. So if you look in the table, as I'm not sure who was talking a while ago, the young man, we know you would have found the value of sine 15 to be 0.259, and the complementary angle is 75. So the cosine of the complementary angle is the same. So cosine cos 75 is also 0.259, right? And 15 plus 75 gives us 90. So 15 plus 75 are complementary. The cos of one is going to be the same as the sine of the complementary angle. That matches it. That's what I mean. So if you look at sine 30, it should be the same as, talk to me, people. Right. Leonardo said sine 30.
0.5.
Cos 60.
Yes. So Leonardo had said sine 30 and cos 60 would be the same. Awesome observation. Great. So work that out and just confirm it for me, please.
Miss, I got 0.5.
Me too, Miss.
Awesome.
And so that would mean that cos 60 would also be 0.5.
There you go. All right, so examine the table, guys, and make sure you are seeing what we are saying.
And while you look at the table and see those similarities with that pattern with the sine and the cosine, look at each column and also see if you see anything happening with the numbers. Whether you see them when they're increasing, decreasing, what do you see happening? Look at that as well.
Or is it totally random?
Yeah. It's one of the key things in improving as a math student is improving your ability, the skill of recognizing patterns and looking out for them and seeing what's happening, what's repeating, what's not repeating. Do you see anything increasing, decreasing? Do you see any similarities, differences? All those things help you to improve as a math student. So look out for that as well in the table.
You can type it in the chat to let us know what you're thinking.
So, Ms. Harris, your question was, do we see a pattern if we look in the sine column? And do we see a pattern in the cosine column? Or is there no pattern at all? Was that your question?
That was my question. And Leonardo is saying for the sine, the numbers decrease, and for the opposite, and the opposite for cosine. But do you find them, do they pass it? Are they restricted in value? What do you notice? Because that's an important thing to realize.
Miss, could you repeat the question, please?
Do the values pass, and can the values pass any certain number for sine or cosine?
Do you see a largest or smallest value?
Oh, Miss, it cannot go over 1.
There you
go. Okay, so then they're saying no more than 1. So does it go below 0? So by the way, this is for acute triangles. You will have different values for larger size angles. So let me just put in that right up front. So this workshop is for acute triangles. So that's a very important point to make. Let me make sure that I make that clear, lest you think that it only can go between 0 and 1. Is everybody seeing that? It doesn't pass 1, it doesn't go below 0 for acute angles. Great.
Ms. Harris, I would like Leonardo to just go through the table and maybe use one significant figure or something like that, just to call out the numbers. Let me make sure that we all understand what he's saying about increasing and decreasing of numbers. Leonardo, can you help me with that?
Okay, thank you, Miss.
Or someone else would like to talk? So the question on the table now is, I want someone to call out the numbers and compare them to let me know what is it? What exactly do you see?
Mhm.
So I could start to say the sign of 0 is 0. And then when I go to a larger angle, what is that value? Is it more than what I'm seeing? Is it consistently increasing or decreasing?
Talk to us. Don't go quiet.
Okay, so I think I will just take it then. So the sign of the smallest angle on the board is 0, and the sign of that is 0. When I go to the sign of 15, which is a larger angle, I notice that the value, the number value for sign 15 is a little bit more than 0, 0.2. And so I'm just 0.3 to one significant figure. And when I go to the next larger angle that is there, it is now 0.5, which is more than the 0.2. And when I go to 45, it is now 0.7, which is more than the 0.5. And when I go to the 60-degree angle, it is now 0.9. Remember, I'm rounding off to one significant figure, which is more than the one before. And when I go to 75, it is 0.96. I don't want to say 1 yet. So I'm going to go to 97. And then when I go to 90, it is more. So it is always increasing. As the size of the angle increases, the sign value also increases. But I also noticed something, as someone said, that the number is restricted between 0 and 1. And in addition to that, I am noticing that it is not increasing by the same amount each time. So it increased from 0 to 0.3, then 0.5, then 0.7, then 0.9. So it's not increasing by the same amount each time. It seems to be varying. All right, but the cosine goes in the reverse order. It's the same numbers in the reverse order, starting with the largest value of 1 and slowly going down a little at a time, but not the same amount each time. That's what I see. Increasing for sine and decreasing for cosine, boxed in between 0 and 1 as I go from 0 to 90 degrees. Thanks.
All right. Thank you so very much. Okay, just give me one minute. I can't. Okay, there you go. All right, great. So
Mrs. Lodge Fenton, one more thing.
Sure.
I would like someone to use a calculator to find the sign, or you haven't started calculator work yet. Should I wait?
No, man, they have.
Okay, so let's do this then. I would like somebody to find this. Okay, I'd like the males to find the sine of 48 degrees. So the males are finding the sine of 48 degrees. And I'd like the females to find the cosine of 42 degrees. So the males find the sine of 48, type it in the chat, and the females find the cosine of 42 degrees. Type it in the chat. Use your calculator. So you're not looking on the table, no, it's not there.
I see the females chiming in. I see the males chiming in. All right. Great work, guys.
Any patterns?
Just a second. I'm seeing a male and a female with the same values. How come?
What's happening there?
Okay, so for males, I got 0.742.
Mm-hmm.
But you're doing two different things. What's happening, Carol? Miss Harris?
I'm seeing a male with the same value as a female. I don't get that.
Miss, you know, it would sound like you're tricking us, but from past,
I like
you guys
that.
said that, seeing that the sine is equal to the cosine, so that seeing that 48 plus 42 equals 90, that means that whatever the males got, the females will get it also.
Oh, that's what's happening. Oh,
all right.
very well.
I like how you put it that I'm trying to trick you. Well, that was not the intention. The intention was to see if you are noticing the pattern. Thank you so much for that. Who was speaking?
Abriana Daly.
Miss
Okay.
Abriana, thumbs up to you. You need many thumbs up for that. So I would like you to propose the next male-female set of numbers, set of angles. Abriana.
Miss, I should create one?
Yes, ma'am.
Okay, hold on. Let me think.
Go ahead.
Okay, so for
And
the males,
Mhm.
sine 33.
Okay.
And for the females, cosine 57.
33 and 57. Okay. Males and females, let's see what's happening here. See if Abriana gets it and if you also get it. So you're practicing your calculator work and you're also noticing a pattern. Two things.
Before we move on, I just want to clarify with Deshaun, please, before we move on and make sure he's okay.
Go ahead.
Miss, they are the same answer.
How come? You can explain? Can you explain why Abriana would know that they should get the same answer? What is it that she used? How did she know that they would get the same answer? Anyone can answer, except
Abriana.
Except Abriana, sorry. Can open your mic.
It's there.
Answer.
Miss, sin 33 is equal to cos 57.
Why?
Miss, because they are the same answer.
Okay, but why would they have the same answer? What piece of knowledge do you now know that supports what you just said? That Abriana used. Yes, Dana, I see you putting it in the chat.
So the sum of the angles must equal to complementary.
Yes.
That complementary, that complement that you have there though is the complement when I say look nice. The complement we're talking about is the one with the E that suggests complete, C-O-M-P-L-E, complete, rather than complement you look nice. But we get the idea. We get the idea.
Yes.
All
so
right.
Because they're complementary angles. Great. Go ahead, Hazel.
I was wondering if Roberts would like to give us the next one. Or event.
All right. And that's I think they would have gotten it.
Just a second, Mrs. Lodgren and Deshaun. You're okay now? I remember in the earlier discussion, yes, I saw you getting that the males and females are different. Are you okay now, Deshaun? Deshaun? Okay, he does say that.
Deshaun said they both complement each other. Yes, so he's
no, in the earlier one. In the earlier one, okay. All right, then, Deshaun.
The conversation is that they are complementary.
In the earlier one, you have made that there, but you're fine now. Great. Okay, we can move on. Thanks much.
Okay, back over to you.
All right. So here we are, and we have looked and we have explored this table, and we now know that we just use selected angles, but you now know, seeing that Abriana would have brought us through an example, and Mrs. Darby would have, made sure you realize that the angles can be random. As long as you find the sign of a given angle, the complementary value of that angle, if you were to find the cos of it, it would be equal to the sine. Okay, and we see that here. Let us not forget the tangent. So I just want you to realize the pattern there. You have tangent angle 0, giving you 0. Tangent 15 is a little bit more than 0. And you see it continuously increasing until you see tangent 45 gives us 1. And then above 45, you would get 1 greater than 1. And tangent 75 gives us 3.732. And look at that. Tangent 90 doesn't happen. Tell me why you think we'd have our error though. What would happen if we have, remember, a tangent means that you're focusing on an angle, one of the angles, whether it be A or B. Why A or B cannot be 90, guys? Hello? Anyone out there?
Please repeat.
Why tangent 90 gives us error? Now, remember that when we're doing any cosine or any trig ratio, we're looking at either angle A or angle B. Well, yes, we're going to use the triangle that we label, angle A or B. Angle A and B, we said that they're what? They're complementary, so they add up to give you 90 degrees. Why can't one of the angle be 90 degrees outside of the right angle? What would happen? Let me ask it again. Can angle A be 90?
Mrs. Lodge Fenton,
Yes.
let us have a talk with them. I would like a drawing of a right triangle.
Let's draw up a triangle. Let us draw one up on there.
Thank you, Mr. Lebo.
Any right triangle. That is a good one. Okay.
I
would like, I'm going to go back. Let's start with the 90. So that's a 90-degree angle.
Put it in, right?
All right. And the angle of concern, let it be the one on the right. Just mark it for me, that angle on the right. So you are now proposing that the angle on the right, which was just marked, was not that size, but a 90-degree angle.
Right.
Can we indicate the line that would make that a 90-degree angle?
Could you repeat that one for me, please?
So
if I want a 90-degree angle at the marked angle,
what would that line be like to make it 90 degrees?
So that would be going straight up, I would think.
Yeah.
Okay. So you could put in the notation to say that that is now a 90-degree angle.
Yes.
So here we have our right triangle where the angle of concern, which is not the 90-degree angle that was there already, is a 90-degree angle. What do you notice about the shape that we have now if that angle was 90? Anything you notice?
Could we get a triangle?
Yes, that is the question. I like that question. Is it forming a triangle? Could we get a triangle? It's no longer a triangle.
Good.
Only Jordan noticed that?
No, there are several persons who we would have put in, because a triangle's total must equal 180. So if one side is
one angle,
they should have
90
degrees, then the total will pass. So if you have 290 degrees, the third angle clearly wouldn't exist.
Good. All right.
So guys, what we want to say is that tangent 90 cannot exist.
It's because the triangle is not formed.
Right. If you were to have 290 degrees angle within the triangle, within the shape, it would no longer be a triangle.
Mrs. Lodge Fenton, I would also, I like that moment. I like that It says,
Wait me. So because in my head, so because one side is 90, that means that hold on.
90.
Hold on. Think it through. Go ahead.
Yeah, because okay. So it could be like 30-30, right? Because it's not when one side is 90, the other side, or yeah, can you just go over that, please? Because
no, tell me why it couldn't be 30-30. When you add 30-30 plus 90, what you get?
150.
Yes.
So
right.
would it
so
be
that's not a triangle either.
That's not a triangle.
Okay.
Is
okay,
everybody seeing Daheem's postulations in the chat? Daheem is asking, can you have sine 89.9999999?
Of course.
It would
And
mean
cosine
that
point zero
the
zero.
angle,
Yes,
yes,
it would
it
be
would mean
almost
that
a
the
flat
sides meet
triangle.
so far up in the sky that we couldn't draw it. I like that idea.
It can't exist though.
I
But it
would
would be-
like to have
it would be a
another look
very
at
tall
something
leg.
else. Could you
Would be
draw a right triangle where at one angle is 45? Or draw any right. Let's start with any right triangle again. Let's start with any right triangle. Okay. 45. So we are talking now as the drawing is happening. We still have that right triangle, that right angle. So I would like you to type in the chat, what is the size of that unknown angle, that last angle at the top there? What would be the size of that angle? We have a right triangle. We have one angle is 45. So that, yes, someone has said it is 45. Because remember that the sum must be 180. Anybody else?
Miss, I think I keep on forgetting that the little, yes, miss, that corner right there is
always
constant. Yes, it's always
Yes.
90.
All
so
right.
I think that's basically what I forgot, which I shouldn't have because that's like the basic thing for any triangle. But
Right.
I see
For any right.
If it's
Yeah.
a right angle triangle, because you can have a triangle that doesn't have a right angle. Remember that, Ariana?
Oh, yes.
So, good. So if we have a 45 and a 45, what type of triangle would have two sides, two angles the same size? What type of triangle is that? Because it's a special type of triangle where two angles are the same. Let me see if they get this one. Miss Harris and Mrs. Fenton, we are talking and we are not talking.
Okay.
Guys,
no, wait, don't. Guys, let me give you a little clue here. You see when you look, no.
Isosceles.
Isosceles.
There you go.
Who said that? The conversation has started. So this is an isosceles triangle. Anyone would agree? Do you all agree? So if you agree, then say isosceles, right? Isosceles in the chat. So if it is isosceles, what do you know about those sides?
Two sides are equal.
Both sides are equal.
Right.
Okay, so let's do some tangent ratio now. So let us say one of those sides is, say, 10 units long, 10 centimeters. If one of those sides would be 10 centimeters, what would be the length of the other side?
10 centimeters.
10
10
centimeters.
10.
So let's find the tangent of that now. Tangent of the 45-degree angle. Tangent, tan 45. Which two sides are we using again? Let us choose the blue one for argument's sake. Then the opposite would be 10.
Blue one.
Yeah, the blue angle, because there's a blue 45 angle and a red 45 angle. All right. Okay. So the opposite side to that, the length of that is 10 units, 10 centimeters.
Yes, miss.
Right. Okay.
Yes, miss.
So and the tangent is the opposite over the adjacent. So that would be 10 units over 10 units.
Mm-hmm.
1.
1. Wow.
So tan,
that.
Tan 45
Suppose the sides
degrees
were not
equal.
10 units long. Suppose they were 20. Would we still get 1?
No, you will get 2.
No, come again.
No, if one side is 10, then the other side would have to be 10 as well. If one side is 20, what's the length of the other side?
20, so it would still be equal to 1.
Because the triangle is isosceles. So the tangent of a 45-degree angle will always be 1 because the opposite and the adjacent to the angle would be the same length. And when you divide numbers that are the same, you get 1. When you cancel, when you reduce to the lowest term, when you cancel using a common factor. So the tangent of 45 is always 1 because when you have a 45-degree angle in a right triangle, the other angle is also 45, which gives you an isosceles triangle, which makes the length the same, which gives you 1.
Don't remove the drawings. Wait a little. So just to add on that, thank you so very much, Hazel. So now we realize that tangent 45 doesn't matter how large, how small, how enlarged a triangle is, it's going to give you 1. Now let us look at another point. What is the longest side in a right triangle, guys? Just name the side.
Hypotenuse.
Hypotenuse.
Good, the hypotenuse. What angle is it opposite to? The hypotenuse is always opposite to the
Adjacent. Right angle.
Listen to the question. The hypotenuse is always opposite to which angle?
Adjacent.
You give your adjacent is an angle?
Angle.
Right angle.
It's always opposite to the, yes. Someone said, Sharona said right angle. Deshaun says right angle. So it's always opposite to the right angle. What is the size of the largest angle in a right triangle?
It's 90.
90. So now let us look at some points there then. So the 90 degrees, opposite to the 90 degrees is the longest side, which is the hypotenuse, correct? Everybody agree with that? All right. So we have the largest angle is opposite to the longest side. So that stands to reason. Now let's look at this 45. The 45 is opposite to what side? If you use any of the 45, you realize that this, because you have the same two angles there, the two sides are going to be the what? The same length. I hope you see that. So now we're going to investigate some other triangles to see if there is a pattern there that you should identify as you're working with right triangles. So hold that thought in your head. So there's one point I want you to remember. The 90 degrees is the largest angle within the right triangle, and it is opposite to the hypotenuse, which is the longest side. That's the first point I want you to hold. Let us carry on.
Mrs. Fenton, still sticking another pin. I would have liked them to have taken a picture of that. I would like to go back to the sine and cosine for a moment, if you will allow me. I would like you to draw an equilateral triangle for me, please.
That's not going to be so perfect, but okay.
That's fine, but at least they know that it is an equilateral triangle. So I'm drawing a triangle where all the sides are the same length. Drop the perpendicular. Okay, that's good. All right. You can remove that little stump there down the bottom.
It is to show that the sides are the same.
Yes, right. So it's just, he wanted to show that the sides are the same. So it's just cleaning out that. No, let those two stay. Sorry. All right. So we're going to give some length to these. So if one side is 10 units, 10 centimeters, then we will have to agree that all the sides are 10 centimeters. Don't write it down the bottom. It's all right, let it stay. Since it's there, let it stay 10. So it is also 10. But I'm going to divide the bottom into 2 equal parts. So I'm going to get 5 and 5.
Okay, so put 5 over there, 5 over there.
Excuse me, is this an equilateral triangle?
It is an equilateral triangle. We deliberately drew an equilateral triangle. Okay, so it is still 10. Thank you for that. Okay, let's talk. Mrs. Lodge Fenton, we are talking. I hope that they will join the conversation.
All right.
If it is an equilateral triangle, what is the size of one angle in the triangle? I'd like you to type in the chat, what's the size of one angle in the triangle?
Equilateral triangle. What are some of the things that you know about equilateral triangles? We already established that all sides are equal.
Thank you, Leonardo.
Okay.
Jaden. Right, 60.
Great. How did you get the 60, by the way?
Yes, Interesting.
180
one
divided.
Divide 180 by 3.
By 3
Awesome
because
stuff.
they are all the same. Okay, yes, Mr. Lini, I see you're set to go. So you could indicate 60 as one of those angles. Okay, all right.
Abriana has her hand up. Yes, Abriana?
Yes, miss. Just asking how you arrived for the 60. I know it's subtracting something from the 180. I just
All right.
Leonardo just typed in the chat.
What do you know about the angles within a triangle, Abriana? The sum of the angles within a triangle, any triangle.
is that they're equal to 180.
Okay, what do you know about the properties of an equilateral triangle?
Is that all sides are equal?
And also all angles.
Oh, as well as all angles.
Yes.
Okay, so that's how
So
we got
that
our
means,
60.
so
Right.
if you have all sides are equal and all angles, if the sum of all the three angles must give you 180, how are you going to find what is the value of 1?
Miss, by dividing the 180 by the 3 sides to get 1.
By the 3
Okay,
angles. to
by
get
the
one.
3. So
Okay.
if you divide 180 by 3, what do you get?
60 degrees.
Therefore, the angles within an equilateral triangle are?
Each one is 60. All right.
Okay, great
All right,
stuff.
Mrs. Lodge Fenton and Miss Harris, let's have our conversation and see if they will join in. At the top, I have divided that angle at the top into 2 equal parts. What's the size of one part? Type in the chat, what's the size of one part?
I'd imagine it's 60 divided by 2, which would what? Is that 30?
Is that 30?
Yes, it is. So that's 30.
Go, Kalisha. Jaden.
All right. Mr. Limi, I think that diagram is crowded. Could you pull out that triangle with the 60, the 30, the 10 centimeters and the 5 and draw it at the side for me? Just draw it one side for me. So I have it nice and separate from the rest of it. I wonder if any student know where I'm going. Let's
where you're going.
Let's just do the 60 alone first. Could you put in my right angle since I dropped a perpendicular?
I would love the 30 to go into, you know.
Not yet.
Okay.
Not yet. I like when we talk because you would like it to go in and I am saying, hold it, hold it, hold it.
And I'm waiting to see where this is going.
Okay. We have some measurements as well. We know the 10 centimeters for that hypotenuse it is now. It is hypotenuse because it is in a right triangle. And we know the length at the bottom is 5. Let us try and find the cosine of that 60-degree angle now. Cos 60 would be what? I would like somebody to type in the chat the values that would give me cos 60. Cos 60 equal, you can start after that.
0.5.
Somebody says 0.5. How did you get that? The others can type the numbers in the chat that they use for the ratio, as Mrs. Fenton and Miss Harris has been saying. What 2 numbers are we using? Cos 60 would be great.
Okay, thank you, Justin.
0.5. Does that match up with our table? Is that the same value in the table?
Looks that way.
Yes, so actually, I don't think we use the table, you know, because we didn't even realize until it's
I know you didn't. And this is exactly so. A question like this can come on a multiple choice where they don't expect you to have a calculator, but you can still find the value because you should know that that if you draw that triangle like that, it would give you 0.5. Now, Mrs. Fenton and Miss Harris, I would like us to look at that 30-degree angle now. So that is why the cosine of 60 is 0.5. We're now going to look at the 30-degree angle. So you could mark it at the top. and we'd like to look at the sine of the 30-degree angle. So the sine of the 30-degree angle, what two numbers will I use? How will I use those numbers? So the sine would be, I'm waiting for it to come in the chat. I'm holding it. I would like to say it.
0.5.
0.5.
How did you get your 0.5? It is opposite, which is? How long is the opposite side to the 30? 5 centimeters, and the hypotenuse is?
10 centimeters.
10, so it's 0.5. And notice that the sine of 30 in the table is 0.5. Notice that the sine of 30 on your calculator is 0.5. Notice that the sine of 30, when we do our calculations without a calculator, we still get 0.5. These are angles that you must know and should be able to do it in the multiple choice. The tangent of 45 is 1, the sine of 30 is 0.5, and the cosine of 60 is 0.5. All right, you might want to take a picture of this.
I'm so happy you did this. I'm going to ask you now to work through with them to find the tangent, to find that missing side for me.
It is going to be tough. Oh, I see what you're saying.
Yes,
you are
I'd like
saying
you
that
to
they
find
have
this
it.
side.
They have information that they can use to find the length of the missing side.
Oh, yes.
Definitely. From any way they want.
So let us label it side X, please.
Or length of X centimeters.
Right. X centimeters. Let us find X centimeter. Can you walk them through that, Hazel?
Okay, I'll give them 30 seconds thinking time. How can we find the length of that side, which is marked as X centimeters long? So I'm waiting for it in the chat. You can either tell me what you're going to do, or if you have completely done it, you can tell me how much it is.
We had talked about it at the beginning when we were looking at the verse start. And some of you remembered, so just use it up now.
Okay. Mrs. Fenton, someone typed in the chat.
I see
You want to
responses.
argue about that? How should I-
Kalisha, you want to tell me how you ended up with 6, and this is 6.343 centimeters? That's what you're saying? I see Dana have 11.18.
Think about that, Danae. Think about that, Danae. Can it be longer than the 10? These are times to think of which side is the longest side. Can it be longer than the 10, Danae? So think about the reasonable. There you go. Think about the reasonable, how reasonable your answer is.
Self-check.
All right, so let us look. So we have the triangle. So the two angles we have is 60 and 30. And we want to find X centimeter. We want to see the value of X. So we have 10 centimeters for our hypotenuse. We have 5 centimeters for one of the side. So let's say I'm considering to use angle 60. I want to find X. What can I use? Anybody? Am I limited to any ratio here?
Mrs. Fenton, do I have to use my ratio? Is there another way?
No, you don't. You really don't. What other way
No,
can
you
we use,
don't.
guys?
Let's not tell them.
Can use angles.
Pythagoras theorem.
Okay,
there
so
you
tell me
go.
what
We
is-
can use Pythagoras.
All right, great. So
And it is
that
not the
means
longest side, so we'll be subtracting. All right.
all right. So tell me what you have, guys.
Your time to work. Do some. Let's see what you have.
All right. You have another 30 seconds and our answers are coming in already. Let's see. Okay, after Pythagoras, I didn't see anything. All right.
Miss,
Yes.
Miss, when everybody was talking about Pythagoras theorem, what exactly are we doing?
You're asking what exactly is Pythagoras theorem?
What's the
Miss,
question?
in where are we right now? I'm a bit lost.
Okay. All right. So we would have
We want
used
to
this
find the
triangle.
length of X. That's where we are. I think that's the question she's asking. What question is on the table?
Yeah, man. But we asked the question, how can we find X? So I had said which ratio we're going to use. And Mrs. Darby asked me if I had to use a ratio. Because there's so much information given in this triangle, I don't have to use a ratio. I can now go back and use Pythagoras theorem if I so desire. Because I have two known sides, I don't even have to worry about the angles that are there. So, and not only can I use the ratio, I can also use Pythagoras theorem to find the unknown side. Understand? If you don't, feel free to say you don't.
Mister, you're just asking how we can find the length of X. So it's not necessarily like so is it that you gave us something or
no, you're just going to find it. No, you're going to use the information you give that's there in the triangle to find the value of the length of side X.
Oh, I see the X now. Okay, because I was trying to figure out which triangle I'm looking at. All right, miss.
Okay, great. All right, Jordan, I see what you've written. Good job. If you're using Pythag, you would have the square of the hypotenuse, subtract the square of the other known side, the square of the other, to give you the square of X.
And then we'd find the square root to get the length.
And then we'd find the square root of it all.
I did see Jordan's, but to put all of that in words, typing in the chat.
All right. Yes, Jaden, I see your answer. And yes.
Danae and Jaden have.
Danae, yes.
Okay, no, sure.
All right.
So many patterns.
All right.
In this that we can pull from.
So can I get the length? And yes, I agree with those answers. The length of the side is 8.66 centimeters. Now you can use Pythagoras theorem, which would state that the square of the hypotenuse is equal to the sum of the square of the other two sides. And then you definitely transpose for X. Now, Mr. Garrick, you said please use a ratio. All right, let us do one of the ratio here. So we are looking for side X. Can we get this on the left-hand side, Giovanni? Let us work it out using one of the ratios. So if I'm using angle 60, side X would be opposite to angle 60. So let me see what ratio I'm going to use where I have opposite and I can use any other sides. I can use opposite over adjacent, which is the tan. So it's tangent 60. Is equal to opposite, which would be X, over 5, which is the adjacent. So it's opposite over adjacent. And then I can transpose for X. All right. What is the value for tangent 60? We know by just looking at the table here, the value of tangent 60 is 3.732. We could do it that way. So yes, so it's 3.732. No, we're working it out. So tangent 60, okay, fine, go ahead. Tangent 60 multiplied by 5 centimeters. Okay, so now I'm going to sub the value of tangent 60, which is 1.733, 1.732. Do apologize, guys. It is not 3.7. It's 1.732. Multiplied by 5. Work that out before, and let's see what you get. Quickly work it out. Just want to make sure you guys are seeing what we are doing. Not just taking what we're saying, but working it for yourself and actually seeing the math, the calculation working out for you.
Brianna is asking you to take it from the top again. So I guess she just needs a talk through.
Abriana, open your mic and talk to me.
Yes, miss. So it's been a very long while. Well, 2 years now since I've actually done Pythagoras theorem. So I vaguely remember the details it contain. So I'm just asking if you could just take it from the top again as to how we even arrive with the x over the 5, please.
Okay, so this is
But
not
that's not
Pythagoras theorem though.
Right. That's trig ratio. So which one you want her to do?
I'm going to do both for you. I'm going to finish this trig ratio that we're doing now. So trig ratios have to do with cosine, sine, and tangent. Pythagoras theorem has to do with, remember that one that you see, c squared equal a squared plus b squared?
Yes, miss.
That's Pythagoras theorem. But we're going to go through the trig ratio and then we're going to work out the Pythagoras theorem to show you that either way will give you the same length. Okay? All right, so let us continue with tangent 60. I didn't have to use 60. I could have used 30 because both angles are there. We know both angles. But I chose to use 60. I chose to use a tangent ratio as well, which state that the tangent of a known angle is equal to the opposite length, is equal to the value of the opposite side divided by the adjacent side. So I'm going to substitute the value. What I've done here, while you have x on the left side, I have transposed for x. I have made x, which is the unknown, the subject of the formula. All right, are you there with me, Abriana?
Yes, miss.
All right, so a simple cross multiplication here. So x multiplied by 1 give me x, and then tan 60 multiplied, whatever the value of tan 60 is, multiplied by 5 centimeter. Are you there?
Yes, miss.
All right. So what's the value for tan 60? Look at the table for ease. 1.732.
Also, miss, you're substituting.
Yes.
Okay.
Then I'm going to multiply it by the 5 centimeters. So plug it in your calculator and tell me what you get.
Miss, I got 8.66.
There you go. All right. So that's using one of the tan ratio. Sorry, did I say tan ratio? That's using one of the trigonometric ratio to find the value of x. Let us quickly go through Pythagoras theorem. Pythagoras theorem states that the square of the hypotenuse, so we're just going to use c. We're just going to use c to just show this the square, the hypotenuse. So Pythagoras, right? Yeah, that's fine. Okay, you're writing it all out. All right, Pythagoras. So now we have the square of the hypotenuse. All right, that's perfect. That makes more sense. So the square of the hypotenuse is equal to the sum of the square of the other two sides. Now, because we are working with the trig ratios, we can call the other two sides the opposite and the adjacent. All right? Because we are aware that if we choose an angle, any angle, there is an opposite and there's an adjacent side to that angle. Agreed? All right. So the hypotenuse we know is the longest side within the right triangle. So that's 10 squared, 10 centimeters squared. is equal to, and now I'm going to put it in relation to, it doesn't matter which is the hypotenuse, which is the adjacent or which is the opposite. We just have to be consistent. So we're going to say 5 centimeter is the opposite. And clearly the other side would be x. So plus x centimeter squared. Put the centimeter in the bracket. All right, so that's Pythagoras theorem right there. So we're going to transpose and have x as the formula here. So since you add 2 sides to get the hypotenuse, if you take away any one of the side from the hypotenuse, you will get the missing side. So now we're going to have 10 centimeters squared is what? 100 squared centimeters. Subtract, just cross it out, make it be a big subtraction. Okay. Subtract 5 multiplied by 5 gives us 25 squared centimeters equal x squared centimeter, or well, all squared for everybody. Yeah, there you go. Perfect. So 100 take away 25 gives us 75. Just write it underneath the 1 over there because we have no more space on that. Let's put it under the 1 in the sign column. Yeah, right there is fine. So 75.
Oh, is right there okay? Where I put a little dot?
Yeah, you can. I just
Okay,
want them
I'm
to
just
be
gonna
able
draw
to.
an arrowhead. Yeah.
Okay. So 75, 70, oops. So 75 square centimeters is this good for you, Brianna? Equal.
Yes.
Right. So we don't want to find x squared. We really want to find x. So we're going to find the square root of both sides, because when you have a value squared, when you find the square root of it, you find the value. So we find the square root of both sides. We're just going to plug it in here for short. So square root of 75 and the square root, that's fine where you, oh. All right, square root of both sides. Find the square root of 75, Brianna, and tell me what it is.
Yes, miss, I got 8.66.
Excellent. So the length of x is 8.66, and we would have used 2 methods to find the value of this. Go ahead, Brianna.
So miss, so because, okay, I think I understand. But hopefully we can get another example so that we could. Yes, miss.
So basically what we did here, we used 2 methods to find the same value. So what we're saying, if you have a triangle with this much information, you don't have to use a trig ratio unless it is specified by CSEC that you should use a ratio. But if it's not, you can use Pythagoras theorem. Okay? That's all that we've done here. But the point I wanted to make, Giovanni, could you put the value 8.66 over the x for me, please? Over the x on the actual triangle. And that we have to move on from the side. We've been on the side for a long time. All right, so what the point I wanted to make, guys, before we lose it, the largest size is what? Just open your mic quickly so we can get through it. The longest side, sorry. The longest side is hypotenuse. What's the value of it?
10 centimeter.
10 centimeter. What is the largest angle?
60.
What's the largest angle within that triangle?
90 degrees.
90 degrees. So look at it. The 90 degrees, the opposite to it is the longest side, which is 10 centimeters. 60 degrees is the next size, is the middle angle, right? It's not the smallest, it's the middle angle. So 60 matches with what? 8.66 centimeters. And the smallest angle, which is 30 degrees, matches the what? What is that side? It is the shortest side. So point to note, when you're working out your calculation, just like how Dana had worked out the X to be 11 point something. And when Miss Harris asked her if it's a reasonable answer, she said no, because the value of X cannot be longer than the hypotenuse. It cannot be greater than 10. So those are points to note as you work with right triangles. You will need to understand that the longest side always matches or is always opposite to the largest angle. The smallest angle is opposite to the shortest side. And you know that middle angle matches the middle length. Everybody's with me?
And that
Yes.
works for any triangle, right or otherwise.
Okay, thank you, Miss.
One more time, Miss, please.
All right. Let us look at that triangle over there. Circle that triangle for me, Limi. The 10, the 5, the 8. That same triangle. Just circle it up so we can make sure we're drawing our attention to this triangle. When we look at the 90 degrees is the largest angle inside that triangle. The longest side is opposite to it, which is 10 centimeters long. Then you have the smallest angle, which is 30 degrees, is opposite to the shortest side, 5 centimeters long. Then that middle angle, which is 60 degrees, is also opposite to the middle length, which is 8.66 centimeters long.
So by opposite, we are saying use your opposite words to find them. The 30 is at the top. The side opposite to it is at the bottom. The 30 is the smallest angle. The 5 is the shortest side. Opposite. You can do that for your left and right. The 60 is on the left. The 60-degree angle is on the left. That's a middle size angle. It is opposite to the side on the right, which is the middle size side. All right. So use your opposite word to find it. So it holds true for any triangle. Opposite the side and the angle, the long and large, small and short. Thank you.
So when we talk about angles, we talk about the smallest or the largest angle. When we talk about sides, we talk about the longest or the shortest. Okay?
Is that a new hand, Abriano, or are you okay?
Yes, Miss, it's a new hand. So I was saying that's okay, I understand, because this 10 centimeters opposite to it is the 90 degrees. I see what you were talking about, where the longest side is going to be equal to the largest degree.
Okay, great.
But facing or opposite to the largest degree, that's right. Largest angle measure.
Facing is a good way to look at it as well. Facing it. All right, so if you need to take a pic of this slide, we are moving to the next slide. Are we good, guys? Do you need a 5 minutes break to go and stretch your leg, or we can continue? If you need a break, just put it in the chat. If we have more than 10 people need a break, we'll break. I see one break coming in. All right, 2 break. We'll just be for 5 minutes and you can go use the restroom and come back, and 24 hours will do for you. Jaden. All right, for those who need a break. So we'll take 5 minutes break. Literally, guys, 5 minutes. It's 11:03. We start
lot
up
to
back.
cover.
I don't know if I should give if 5 minutes. I'm giving you 3 minutes. So it's now I get to 11:08. Would you listen? You get 3 minutes to go to the restroom and come back. We return. It's now 11:04. We come back at 11:07. 3 and 4 is 7? Yes. Yes. So I'll see you back in 3 minutes. Quickly go and use the
Already
bathroom.
we need to move on. It's a lot to cover.
Yes, but let them take a little break and come
They
back.
need a break. They do. Brenda said she needs to process.
All right. All right, guys, take your break.